easier to navigate by using their module. But y'all should have. Oh, I see more people. I see Alexis and Bailey. Is that you, Jared, that I hear making noise over there to my left? Who is it? Uh-huh. Turn off. The music, I'm hearing, it's coming from your general direction. Uh-huh.
I'm smarter like that.
You're smarter like that. Uh-huh. But you got it? You got it now. Okay. Like I said, it's going to take a couple minutes to do the quiz. I'm not trying to drag my feet super slow, but I do need to give you all a couple minutes to do it. Boys, shh. God. I'm trying to do this. Yep, I did. And then we're going to get started up into the notes here in a second. So I'm going to put the first thumbs down. No, I don't want to. To you guys. I don't know. What's going on? Nothing. Nothing. Okay. Mm-hmm. Really the only thing that y'all have in Parent Portal is the test. I can't remember off the top of my head if there was anybody in here that missed it, but I have to go back and hand grade them. So if you were absent, if you were absent and you did the test, you need to inform me in some way, shape, or form so that I can go back and hand grade it. It's not moving over into Canvas properly. There's some of them, if you got partial credit, I have to give you the partial credit. It won't do it for you. It just marks it all wrong. Oh, my Lord, my computer is so slow.
What?
It's so slow. Oh, Jimmy. Okay, I'm just gonna keep my mouth shut. And he's proven the point again, Jimmy. So Bailey and Veronica. Oh my Lord, y'all. Bailey and Veronica.
Did you throw me on that hill when you were born? Oh my God, I was dropped.
And you laugh.
When I was like, I don't know what happened. Yeah, but I was like a year and 2 months old. I broke my toe.
TV through skipper.
No, I'm not slow. I was so big.
Oh, goodness gracious, y'all.
Went to get up, I'm like, no, Freddie got it. That's the bottom of it. Couldn't get my toes out. Then broke my toe.
Okay, I'm seeing openers from a few days ago from Slate and from Valerie. I haven't put openers into the No, I haven't put them into the like parent portal. Like I mark them. I just haven't. I have to have like the halfway point in order to what? No, I'm saying that somebody possibly was absent and didn't do it, and then I saw it and I'm recording it, but I've not put it into parent portal. Is what I was saying. Don't hate people. All right, have I given y'all enough time to do this quiz? I hope. Maybe. Here, let's look. Let's look online. I cannot stand Canvas. Yeah, it looks like most of you have actually done fairly well on it. Alrighty, so yeah, y'all. Shh. Hush. We are still working on making ions. And some of you are going to like ionic compounds way more than covalents, and some of you are going to love covalents way more than ionics. I always have some students on either side of said coin. We got, but for notes 20, we're going more into Lewis dot diagrams. Some of the other chemistry teachers smooshed this all together. I kept it separate. It might be a day behind, but it's okay. I'll make it work. And Caitlin, I thought I saw online. I did. Slate, I saw online. So hello, Tiffany. Lucas. I think Haley's in here. He's not there. Alexis, I saw online. Jimmy's in here. Sebastian's in here. Kyle, but I don't see Matt here. Unless if you're online, Matthew, I'll check in just a second. Luke got in trouble again. The less I know, the better off I am. Robert, Leah, Reagan, Aiden.
Yeah.
Did you take that test, Aiden? From Tuesday? You did? Okay, something in my brain is making me think that you were missing something. No, you did. I got it. I do. I've got it.
That was not a secret.
Okay. Okay. It's with 240 students. It all just sort of blurs. But no, I knew something was going on with you, so I think I've taken care of all of it. I'll double check it when we're done with this to make sure that I actually, because I have it on here, that I put it in the parent portal. And so we are still going into making ions. Somewhere I put my cookie thing. There it is. But the octet rule, we talked about the octet rule yesterday. The octet rule does not really mean 8. Yes, I know the prefix oct, like octopus, octagon means 8. You normally want 8. There is an exception, and that exception is helium. Helium wants 2. So really what the octet rule says is that it wants to be like its closest noble gas, which, yes, most of the time is 8 electrons. And most noble gases, electron configuration, has an S2P6, and 2 plus 6 is 8. Like I said, the only exception being helium, which is an S2 configuration. So when you add, I'm sorry, those of you that are online, but when you add these superscripts, If you're dealing with a 2-6 relationship, which adds up to 8, this is a noble gas, with the only exception of helium. And like I said yesterday, I am so sorry, but this class is full of but except for this. I did not create chemistry. I like chemistry, I understand chemistry, but it's got a whole bunch of these weird, except for this situation. Just remember this weird exception to the rule. I think y'all are done with this one. And there are no go back. So, sure. You do need to go back? Okay, hold on. Because I don't have this puppy in front of my face. Oh, that's the actual assignment. That was not the one that I wanted to pick up. Okay, so the octet rule is the first one. I do really try to underline like most of my stuff so that you guys can fit into it. The octet rule says that atoms react by changing the number of their electrons to acquire the stable electron structure of a noble gas. It is usually S2P6, which is 8 valence electrons, but for helium is only S2, which is 2 valence electrons. That was that top one. Got it? When we do this, when we gain or lose electrons, we either become positively charged. If we lose electrons, we become positively charged. Those are capped ions. The T is the positive sign. Those are almost always metals. And if they gain electrons and bring in more negatives, become negatively charged, those are normally non-metals, and those are called anions. Huh? Well, I mean, you need to know that the cations are the positive ones and the anions are the negative ones. That was on actually yesterday's notes, like separately. Is it like explicitly on this one? No. It's just an ion is either a positively or a negatively charged atom. You cannot change protons, change the element. We're not even dealing with neutrons anymore. Those were isotopes. Ions deal with different numbers of electrons. More electrons is a negative charge in anion. Less electrons is a positive charge is the cation. Oh, I'm so sleepy today. I did not sleep well at all. That's why you don't want to do anything.
Yeah.
Mm. Now, I don't think you guys have this one on your page. At least not the paper that I'm holding in my hand. Cations don't change their name. It's whatever the element is ion. It's a sodium ion. It's a manganese ion. It's a boron ion. It's a rubidium ion. It's a strontium ion. It's an yttrium ion. They don't, it's just the element's name. Anions, however, and this is going, I'm sort of stepping into next week a little bit right now. The anions, their ending changes to "ide." There are a few weird ones, but most of them you basically replace the last few letters with the suffix "ide." Oxygen becomes oxide. Nitrogen becomes nitride. Fluorine becomes fluoride. Fluorine becomes fluoride. Bromine becomes bromide. Sulfur, phosphorus, and oxygen are the three that people don't spell right. It's not oxide, it's oxide. Phosphorus becomes phosphide, and sulfur becomes sulfide. But most of them that end in INE, it just switches to IDE. And like I said, I'm sort of jumping into next week a little bit. This is called nomenclature. It's how we name these things. Well, your metals, they don't change. It is a beryllium ion. It is a barium ion. It's a francium ion. It's just the elements. It's the non-metals that we tend to switch the endings. And yes, they end in I. No, I don't think you guys have this one on your actual page. Examples, sodium. Sodium is Na. It is this guy right here, number 11 on the periodic table. Its electron configuration, so first row, both S's, so 1s2. Second row, both S's, 2s2. Second row, all 6 P's, 2p6. Third row, first element inside the S cloud. And so sodium's electron configuration is 3s1. It is much easier to lose 1 electron than it is to gain 7. They will do the shortest path. Whatever's quicker, whatever's easier, you can call them lazy if you want to. It is easier to lose 1 than it is to try to obtain 7 more from something else. The next one, fluorine, this guy over here. I am in the second row down within the P block, and I am the 5th element over. And so the very last thing that I should see is telling me that I am the 5th element over within the P block on the second row down. I just honestly think we should have flip-flopped what we did last week with what we're doing this week. If it has 7, it's easier to gain 1 than it is to lose those 7 electrons. And then we're going to go through a whole bunch of what is on the assignment together. Well, actually, it's not on the assignment. It's this bottom part. But it's what we have to be able to do for said assignment. All right. So, first thing, barium. Barium is in group 2. It's the second one over. It's right here. And I did print off more periodic tables if any of you need to redo one for whatever reason you lost it. It got melted in the rain. I don't know, whatever the excuse is this time. But barium has 2 valence electrons because it's in group 2. It's Lewis dot structure, which I'm actually going to put the dots on the left-hand side, not on this side. I didn't realize I was putting them in the wrong spot when I created this last weekend. It was just a mistake. But barium has a total of 2 dots. Really, what I'm doing over here should be over here. I didn't even catch it until today. How do you do a dot? You don't. You draw a dot. So on your Google Doc, shapes. Right, so insert. Right, and then you have the ability to create a dot. Go hover over image. How do you guys create dots with Google Docs?
It's easy. Is it not in your script?
Like that. Now can you drag it over to where I want it to be though? Because I normally, like if I show you, like if I get out of this screen, like, I mean, this is the entire thing, so don't cheat. But, well, she wants to put a dot. on either sides of the barium. And with here. Let's see here on a Google Doc, it is, I thought it was under insert. All I want is a dot. It is so much easier to do this with just pencil and pen and paper. I don't know how Google Docs does those. Not a photo. Can you actually use like a pen or a pencil and like make an actual dot? Why do I have to make this so hard? Ah! What? Insert? Yeah. Here, shape, shapes, circle. There you go. That's what it is. Save and close. And then you can drag it to where it needs to be. Is that the way it works? Okay, awesome. Thank you.
Oh, really? You just didn't tell us about that?
I forgot about that because I had a separate ad.
Well, it's just, I mean, honestly, this whole year is just like a learning curve on trying to make sure that everything is taken care of. But, hey, so barium has 2 valence electrons. It is easier to lose the 2 electrons than it is to gain 6. And if you lose 2 electrons, it becomes a positive 2 charge. So the barium ion, not the element, the ion is Ba with a +2. It did work. Perfect. Learned something new today. Again, I can't remember. I learned something new yesterday, but I can't remember what it was. It's something.
I'll just search it.
Nitrogen. Nitrogen is in group 5, so it has 5 valence electrons. It gets 5 dots. Oh, and in order to make more dots, if you're trying to make new ones, when you click on it, you hit Control C and then Control V, and then you can like move it where you need it to be. There are, exactly, copy and paste. There is a very specific way that we put dots around these symbols. They are in a box formation, not a circle formation. We tend to do our cardinal directions, left, right, up, down. And then we start clockwise with the top. This one, nitrogen is 5, so literally left, right, top, bottom, and then top. If I had 6, it would be to the right, 7 would be on the bottom, and 8 would be on the left. Not circular, box-like. If I have 5 electrons, it's easier to gain 3 than it is to lose 5. Once again, they do whatever the shortest path is every single time. So it's charged, if it's going to gain 3 negatively charged electrons, what is its charge? -3. And the symbol would be a capital M with a -3. That is the whole reason why we did the +1, +2, +3, +, -4, -3, -2, -1, 0 across the top of the periodic table. That's where these numbers are coming from. And it gets a little bit more complicated when we do transition metals, the short squatty part in the middle of the periodic table that we are very much ignoring right now. Carbon's in group 4. It has 4 valence electrons. Its dots, 1 on each side. Top, down, left, right. It is either going to lose or gain 4. Your group 4 elements are very handsy. They grab onto everything. Is that you that's still making noise, Jared? No, liar. This is why we put a + or -4 above group 4. There's a reason why we're carbon-based life forms. If there's any other type of life in this universe, it's probably silica, but to our knowledge, everything that is alive is a carbon-based organism. Every single gosh darn thing. So it could be plus, do what now?
No.
Anything that's lived at one point in time. Plants, animals, bacteria on this planet is a carbon-based organism. Every single gosh darn thing. The hypothesis is maybe in the reaches of space, we might have silica base, which means they don't look like us, they basically look like sheets of glass. Because I'm not alien, I'm talking about like hypothetical stuff.
GMT.
Basically, yes.
I think I was right about him being a bit smart.
But silica has 4 arms, just like carbon does. Has 4 valence electrons. And like I've said before, it's these valence electrons that lets atoms talk to other atoms. Now, neon is a noble gas. It has all 8. Like I said, technically the lowest dot should be on this side. Like I didn't pay attention when I made this last weekend. I put them in the wrong spot. If it has 8 electrons, does it want any more?
No.
Nope. So it is inert. There is no such thing as an ion for a noble gas. Helium is the one that I am going to try to trick you with. How many electrons does helium have? 2. Has 2. Does it want any more?
No.
Nope. It is the only noble gas that only wants 2 electrons. And this is what you guys are doing with the assignment that was built on the canvas. I'm going to freeze this. I do have a paper version of this because I know some of you prefer the paper version. I haven't even graded the most recent paper one. I'm about to do that here in just a second. Who wants the paper version? We all do. Okay. It is in Canvas.
Why don't I take a picture of it and send it in there?
Okay. You sure can, and then upload it. Yes, you can.
I turn it in.
You can turn this into yes.
You know,
Who else paper version? It is the exact same thing. It is on Canvas. As long as my kid doesn't have close contact on the playground with the elementary school, and we don't have this issue. That was not fun. And yes, I'm pretty sure I said bad words. In fact, stomping on my computer. The kid trying to fall on my lap. I was super frustrated.
No. No, Jamie forgot to talk about this.
Really?
The only bog one can tested positive. Yeah.
our game got canceled Saturday because January school all got quarantined. So they're shutting the school down for a couple of days.
Well, they're shutting school down just for at least 2 weeks. It won't be for a couple days, it'll be for 2 weeks. Who else said they wanted a paper version that I missed? Okay. Yes, paper version.
Where's that?
No, I'm so not wanting to do this crap from home. I'm not. And I'll say that as politely as possible. Don't mean crap like I don't like y'all or anything like that, but no, this is not fun doing this remotely. How do I know I just went through it? Oh, I thought you meant me.
There was a Monday I was in here.
So, this is on Monday. Oh my God. You